some physics problem. A jogger runs halfway around a circular path with a radius 21 meters. So someone is running around a circular path of a radius 21 meters. What is the magnitude of the displacement of the jogger? So he moves half of the circle, halfway. So let's say he was here at point A, so he will run half of the circle. So he moves from A to B. What is his displacement? He says, what is the magnitude? What the magnitude of the displacement? What do you think? He was at A and he moved to B. So the displacement is directly from A to B, which is the diameter. Okay, I have here 21 meter and here 21 meter. So the total is 42 meters. So the magnitude of the displacement is the diameter of the circle, which is 42 meters. Okay. Let's see something else. A boat moves 6 meters per second relative to the water. So this is not the real speed. This is relative to water. So a boat moves in the water with a speed v boat relative to water equals 6. Okay. Excuse me. If the boat is in a river where the current is 2 meters per second, the current itself, the water itself, moves at a speed 2 meters per second. How long does it take the boat to make a complete round trip? Complete round trip, it goes forth and back. So that's a complete trip of 1,000 meter upstream followed by 1,000 meter downstream. So let's say the whole distance here is 1,000 meters. So we need the boat to go forth and then returns back. So we need to calculate the time. What do you think, guys? When the boat moves in this direction, in the same direction of the stream, what's the real speed of the boat?
8.
So the real speed of the boat equals, or we can say the V boat, the equation that we know, V boat relative to water. V boat relative to water equals the speed of the boat, or it should be the velocity here, not the speed, minus V of water. Both are moving to the right here, according to my drawing. So V boat relative to water is 6. V boat is the one I'm searching for, minus V water is 2. So V boat here is 8, as you said. That's right. So 8 meters per second, because as you know, if the boat moves in the same direction of water, the water will increase its speed. The water increases its speed because of the flow. The opposite will happen if it moves opposite to the current. It will be 6 minus 2 is 4. Okay, as we will see when we calculate it. So V boat here is 8. So that's if it is moving to the right. So what's the time required to cover 1,000 meter? Distance is 1,000. Speed is 8. What's the time? How to calculate the time? The distance equals speed times time. The distance equals speed times time. So the time equals the distance over the speed gives us what? Can you do it, guys? Please use the calculator to find it. Huh? What is it?
125.
125 seconds. So this is the time required to go forth. To go back, it will be the opposite. So when the boat goes back, we know the current is to the right, 2 meters per second. So that's V water. And V boat relative to water, V boat relative to water is 6. It does not change, but the direction here changes. So what's V boat? The same situation. V boat relative to water equals V boat minus V water. V boat relative to water is 6 to the left, which is -6. V boat is the one that we need to know. V water is 2, which is to the right, so I will keep it as it is. So V boat equals -6 plus 2, which is -4 or -4. So the speed of the boat, the real speed of the boat is -4, meaning that this boat moves to the left at a speed 4. The velocity is -4, the speed is 4. So I will do the same. The distance also equals V times T. So the time T2 equals the distance, which is 1000 meter, divided by the speed 4, gives us what? 250 seconds. So the total time equals 125 plus 250 gives you what? 375 seconds. 375 seconds. Do you have any question in this one, guys?
No, thank you.
Okay, great. A cart of weight 264.6 Newton is accelerated across horizontal surface at acceleration 0.65 meter per second square. So what's the net force in Newton acts on the car? On the cart. I have a cart, moves, it has a weight W equals to 64.6, and it's accelerating at acceleration 0.65. We need to find the net force. Net force, what do you think? Any idea? I know Newton's second law says what? Net force equals mass times acceleration. He's asking about this net force, so we need to know the mass and the acceleration. Acceleration is given 0.65, but how to get the mass, guys? How to get the mass? Anybody?
Divide the weight over
Using
9.
the weight, that's right. Excellent, using the weight. So I will divide the weight, which is 264 over G. So this is the mass. I will multiply it times acceleration, gives me the net force. Could you please do it? What's the result? Anybody?
$17.55.
17.55 Newton. So this is the net force. Okay. Let's see. We have something else. A worker does 2,588 joule of work on a 48 kilogram crate to push it up an incline. So there is a crate a worker tries to push it up, so he applies a work, the work of worker, which is the input work, by the way, 2,588 of joules. The mass of this object is 48 kilogram. To push it up an inclined plane, if the efficiency of the plane is 50%, efficiency is 50%, what is the vertical height of the inclined plane? You need to push it up. So here I have output work and input work. The output work is the work that the worker does, which is 2,588. Sorry, that's the input work, not the output work. The input work is the work that the worker does. The output work is what? What's the output work?
MGH.
MGH. The mass is 48 kilogram times 9.8 times H. I don't know H, but I know the efficiency. Efficiency is 50%. So I will say efficiency equals output work over input work times 100. So 50% equals output work, which is 48 times 9.8 times H times 100, because there is 100 here. Okay, let me do it here, 100, divided by the input work, which is 2,588. So can anybody find H, guys? What the value of H? Hmm.
$2.75.
Over 100, 2.7509.
75.
So let's take 2.75 meter. Okay, so this is the height. So that's between the efficiency and the work. A fireman who has a mass 80 kilogram slides down a pole, like there is a pole, like in the fire station, for example. So he holds this pole to slide down. He has a mass 80. When he reaches the bottom, 5 meters below, so he slides down 5 meters down. Of course, he starts from initial speed 0. Okay. Below the start point, his speed is 2.5. So the speed when he reaches here is 2.5 meters per second. How much thermal energy increased during his slide? Of course, when he slides down, there is a friction. So this friction meaning what? He loses energy. This energy usually turns into thermal energy. The friction force produces energy, or actually it takes energy from the object. This energy is in the form of thermal energy in general. So how much energy is lost? Let's calculate the mechanical energy at the beginning and the mechanical energy at the end, and let's subtract them. Okay, and the difference is the loss by the friction, which is thermal energy. So what is the mechanical energy in one? It's mgh, because he has 0 speed. He starts the slide. So his mass is 80 times gravity times height, which is 5 meters. What is the mechanical energy at the end? It's kinetic, half mv square. So half times his mass 80 times 2.5 square. So now I know the mechanical energy at the end, the mechanical energy at the beginning. Let's find the change in mechanical energy. What's the difference? Could you please do it? Half times 80 times 2.5 square
3670.
3670 joule. So this is the difference in between. Okay. So if you subtract the first mechanical energy minus the second mechanical energy, it gives you the loss. Okay. What if he said, find the average friction? Find the average friction during the slide. This loss is energy. Okay. And it's equivalent to the work done by friction. This energy is equivalent to what? The work done by the friction. So I can say this is equal to the friction force times the distance of movement, because this is the work done by friction. So the distance here is 5 meters. So the distance here is 5 meters. So I can equate the loss, which is the loss of energy, with the force times 5. So I will get the friction. So let's assume that he asks for the average friction. You can do that. Find the loss and then equate it to friction times distance, because this is the work done by friction, which is the loss of energy. Okay. But of course, here he didn't ask for the friction. So he asks only for the change in energy as thermal energy. Two masses, M1 and M2. M1 is 3/4 of M2. They have equal magnitudes of momentum. How do their kinetic energies compare? So let's say the momentum 1 equals the momentum 2. What is the first momentum? Mass M1 times speed V1 or velocity V1. What is the second momentum? Mass M2 times the velocity V2. Okay, he said they are equal. But the mass M1 equals 3/4 mass M2. So from this equation, I can remove M2 with M2. So I get a new relation that V2 equals 3/4 times V1. So this is the relation between the velocities. Do you understand this point? So I equate the momentum. Momentum equals momentum. So mass times velocity equals mass times velocity. And then there is a relation between mass, so I got the relation between velocities. Then he asks about kinetic energies. Kinetic energy 1 equals half times M1 times V1 square. Kinetic energy 2 equals half times M2 times V2 square. Okay. If we remove M1, we can rewrite it as 3/4 M2. And if we also remove V1 from here, we can say V1 equals 4/3 V2. So I will remove V1. I will rewrite it as 4/3 V2, and I will square it, because V here is squared. Let's try to simplify it. The square here is removed with the 3/4. So at the end, it will be 4/3 times half M2 V2 square. What is this part? This is the kinetic energy 2. So it's 4/3 kinetic energy 2. So kinetic energy 1 equals 4/3 kinetic energy 2, which is here. Okay. Do you have any question in this one, guys? So there are two steps. I equate I equate the momentum. Okay, so I get the relation here between the speeds. Then I will try to find the kinetic energy of each one, K1 and K2. That's K1 and that's K2. Which of the following statements, which of the following statements is false? False. Let's see. It asks about the false statements. Evaporation takes place only at the surface of the liquid. What do you think?
No.
Evaporation, not vaporization. Vaporization. What the meaning of vaporization? It's the change from liquid to gas at the boiling point. This is called vaporization. Evaporation is at any temperature below the boiling point. The vaporization, it happens throughout the liquid, inside the liquid. While the evaporation, it happens only in the surface. So the evaporation, it happens only in the surface. So this is a right statement. It's a true statement. Okay. Diamond is an example of amorphous solid. Diamond. Do you think diamond is amorphous solid? Mazen and Khalid, do you think diamond is amorphous solid?
I don't know, doctor.
What's the meaning of amorphous solid, guys? The particles are arranged randomly. They are arranged randomly. Okay? They don't have a certain pattern. Do you think diamond is random? Diamond is a crystal. Diamond is a crystal. So this statement is wrong, because diamond is a crystalline solid, not amorphous solid. Okay. The formation of the clouds in the sky is an example of condensation. تكثف. So the formation of the clouds is an example of condensation. Yes. Yes. Because the water condenses to form clouds. The density of water increases when you cool it down from 4 to 0. So when you cool it down below 4. So when you decrease the temperature below 4, do you think the density increases? No, the density decreases. The density decreases because we said before it changes into crystals, and the crystal becomes bigger because it takes more volume, the crystal of the water. So if it takes more volume, if the volume increases, that means the density will decrease. So the density of the water does not decrease. Sublimation is a change from liquid to gas. What do you think? Sublimation at Tasami is a change from liquid to gas? No, it's from solid to gas. Temperature is the average kinetic energy of particles in a substance. Is the temperature the average kinetic energy? Yes, the temperature is the average kinetic energy. The temperature at which the solid starts changing to liquid is the boiling point. Solid changes into liquid. Boiling?
No.
Of course not. Okay. This is the melting point. Melting point. Melting. Gas does not have a definite volume or shape. Gas does not have a definite volume or shape.
Oh.
That's right, true. Gas does not have a definite volume or shape. So as you see here, he was asking for the wrong guys. Let's see this one. A basketball has a mass 0.5 kilogram and a volume 8 times 10 to negative 3. So we know the mass, we know the volume. What is the magnitude of the net force on the basketball when it's fully submerged in water? So I have a ball that I will submerge it in water. Okay. What's the force on the ball now? I have the weight downward and I have what? Buoyant force upward. Okay. So what's the weight of the object? Mass minus gravity, which is half times 9.8. What about the buoyant force? It's rho times V times G. Rho of the liquid, density of liquid. V submerged, the submerged volume, times gravity. What's the density of the liquid here? Is it water? Water. So the density is 1000. What is the submerged volume? He said fully submerged. Fully submerged, and the total volume is 8 times 10 to negative 3. Times gravity, 9.8. So this is the buoyant force. Subtract the two forces. So buoyant force minus weight gives you the net force. Can you please do it? This 1000 goes with the 10 to minus 3. So it becomes 9.8 times 8 minus, or you can say 8 minus 5 times 9.8. It's up to you. So it gives us 73.5 Newton. So this is the difference between the two forces. Okay? He might ask you the same question in another way. He might say, if somebody holds the ball under the water, how much force do I need to apply on the ball to keep it under the water? The force is 73.5. Okay? So he might say, how much force do the player need to apply on the ball to keep it fully submerged under the water? Because the ball will not be kept under the water. It will move directly upward. That's normal. It will be like that. So to keep it under the water, you need to apply a force. How much force is required? 73.5. If you apply it, you will keep it under the water.
دكتور
Yep.
ايش الفرق بين الفي حقة الفوليوم وعند the V حقة الفيلوسيتي؟
The symbol you mean?
This the symbol.
I think the velocity and the volume, they have the same symbol, almost. They have the same symbol.
Okay.
Although the volume, the velocity, sometimes they make it small. They don't make it bigger one. The volume, usually they make it capital, bigger one. Okay, capital and italic in some cases, like this. This is the volume. The velocity, they might make it small.
Okay.
Okay. The speed, they make it like this. Yeah. Okay, small and italic. Okay. So this one. Okay. So choose the correct classification for. We need to classify gasoline has a pungent odor. Is it a physical property or a chemical property or a physical change or a chemical change? The odor of gasoline. Is it a change or a property? Gasoline has a pungent odor. Odor means رائحة. رائحة لاذعة. Okay. So he's talking now about a change or a property. It's a property. Is it a physical property or a chemical property? The odor.
Chemical.
The odor. The odor of the element. Is it physical or chemical? Something physical.
Physical.
Okay. So it's a physical property. An enzyme breaks down the lactose in milk. So there is an enzyme. It breaks down the lactose in milk.
Chemical.
Chemical. Chemical what? Property or a change?
Change, I think.
Chemical change. An ice cube melts to form liquid water.
Physical change.
Physical change. Nitrogen has freezing point at negative 210.
Physical property.
Physical property. Cesium metal. Cesium is a metal. Cesium metal reacts explosively with water.
Chemical change.
I think here it should be chemical property. Should be chemical property here. But because he says reacts, not. Because here he describes, I think, like he describes a fact. بيصف حقيقة علمية. That the cesium reacts explosively with water. So it should be a property. But here he says it's a change. I don't know why.
Maybe because explosively.
No. The cesium metal reacts explosively with water is a fact. It's a fact. حقيقة علمية. So we are talking about a property. Okay. The cesium metal reacts explosively with water. Anyway, so you make it a change. But it should be a fact. It should be a fact. So it's a property, not a change. Anyway, let's see if we have more questions in this one. I think you are familiar now with the earthquakes. Okay, the P wave and the S wave. Okay, can you determine the lag time and the distance? I think there were a lot of problems in the homework and in the quiz for this one. Okay. So let's take this one for example. Do you have the textbook with you guys? Do you have your textbooks? So using the graph of the lag time, you will find it you will find it in the slides, or you will find it also in the textbook, page 786. 786 in the textbook, or you can find it in the slides in 25.3, no, 0.2, in slide 25.2. He says here, if the distance of the seismic station from the earthquake is 2,500 kilometers, what is the lag time? What's the lag time? Look at the chart and find the corresponding lag time for the distance 2,500. 2,500. So what's the corresponding time? Look at the chart. 4. That's right. So you will find it exactly 4. Which of the following? Yes.
How did you calculate it?
How did I get it?
Yes.
Tell you just 1 second. Let me show you the graph and let's do it together. This is the graph. He said 2,500. So the distance is here. 2,500. So I will move vertically. I need this time. The time in between. This time. It's between the 5 and the 9. So that's 1, 2, 3, 4 minutes. Okay, so the time in between, which is the lag time, is 4 minutes. Do you understand it? Got it?
Okay, yes, I get it.
Okay.
So there is no method way, just by looking to the chart.
Now they don't look at the chart. In the old days, they used to look at the chart. But today, everything is made by computer. But in the exam, you need to look at the chart.
Okay.
Which of the following which of the following statements is correct? Which one is correct? The convection current in the mantle causes the motion of the plates. You remember when I draw you the convection currents and I told you if we have 2 plates, they will move? So the convection current causes the motion of the plates? Yes. Alfred Wegener uses sonar images of the seafloor as an evidence for his continental drift theory. Did he use the sonar? Alfred Wegener. Did he use the sonar? Of course not.
No.
Harry Hess used the sonar, not Alfred Wegener. The surface waves are the fastest seismic waves?
No.
Of course not. P wave is the fastest. P wave. The primary seismic,
Yes, surface waves is the slowest, right?
Yes.
Okay.
The primary seismic waves are transverse waves. The primary are transverse?
No, S wave are transverse.
It's compressional. Or you can say the S wave is transverse. So you either say the primary is compressional or the S wave is transverse. So it's wrong. There are 4 shadow zones for any earthquakes. There are 4 shadow zones. You remember when we said the waves will move until they reach to a certain angle? which was 103 degree. Then we will find nothing after that until you will reach to 140 or 145. Then you will receive again the signal. So there is a shadow zone here, and there is a shadow zone here. There are two shadow zones. Okay? There are two shadow zones, not four shadow zones. So this is wrong. The density of the Earth's interior layers increases by depth. Huh? The density increases when you go inside.
Yes.
Yes.
I think.
Yeah, normally because of the pressure. The pressure increases, density increases. Okay. Okay. This one, we don't need it this semester. It was cancelled this semester because of the time. And also this one, the radioactive time. And also this one. So that was everything. Okay, guys, that was everything today. Thank you so much for watching the revision. And please ask if you have any question.